Greeting to my lecturer and fellow friends. Today I'm going to present the Lab 1 Part 1 for its CPU instruction for the subject of Electronic Engineering Laboratories 4. So let's get started. So firstly we need to add a program. So I name the program as LPS1 and then I choose the 100 as my base address. Then click add to this program. This will be shown here for my program to start. So the left side is a list of the instruction lines, how to add. So we click here for the left bottom corner. We click instruction and add new. Here are all the categories of the opcode to perform the CPU instruction. You can see all the opcode for the instruction. The source operand, you can either choose value or register to implement to the destination operand of value or register. So for the first line, you can see this is MOV, which is move. This instruction line describe we move the value 5 to the register 00. So I double click. And you can see the value of 5 is shown at the register 00. So the second one is the same as the first one, but we change the value of 5 to 8. And then the register will be 01. And then I double click again. It shows the value of 8 at the register 01. So the third line is we add both of these values of the registers. Then I click. It will be 13 since I add between 8 and 5 and become 13 and shown at the register 01. Then the PHS, which means we push the value of the register 01 to the program stack. And you can see here, it's shown here. And then the next one is same as it's before, but we push a value which is -2. And then we also shown the negatives 2 here. And the next one is CMP, which means compare the values of register 00 and 01. So I double click it. So we need to observe the status of here from the SR status flag. Since it doesn't have any tick of any box here, so we can say that the output for the comparison of register 00 and 01 is positive. And then the next line is JMP 0, which means we jump to the first line, which is the origin of the instruction. So I click this, and then it jumps back to the origin of the instruction, which is the very first of the move value of 5 to the register 00. Okay, next we will say this is pop, which means we push the value from the program stack to the register 02 with double click. And you can see I push the value of the -02 to the register 02, which means which also can call it as I pop the value to here. And then it is same as the next line. We pop the content from the program stack to the register 03, which is shown here. 13 shown at the register 03. And here is the CMP, which is mean we need to compare the values of register 04 and 05. But here it doesn't show any value, so we need to insert manually. So we click here, and then the bottom here we have the red value. So for example, I choose the R04 is 7, then I click change. And then the R05 I choose 6, then I click change, and then it's shown here. So once I compare, since the value of register 04 is bigger than 05, then the output will be negative. So status flag here is tick at the box here for the negative indicate. If the value of register 04 is smaller than the value of the register 05, so once I compare again, it doesn't have tick here, so which means it is positive. But if both are same values, for example, we change the register 04 to 7, same as the register 05, then I compare again, it is shown as the output of its comparison is, for its output is 0. So it shows a tick for the indicator 0 here. And then the next line is JEQ 0, so which means jump equal 0, which means if this R04 and 05, their values are the same, it will jump back to the origin of the instruction line. So I click again. Yeah, it is moved to the very first instruction line. But what if we change the value of R04, which is different to the R05? You can see after we compare again, and then we click the JQ, it doesn't jump back to the origin of the very first instruction line, but proceed. And then for the very last line is SUB, subtract the value of R04 and R05. Once we click, it shows the value of the answer, which is 7 minus 6, which equal to 1. Which also indicates the subtraction between R05 and R04. But if we try again, we change the value of R04, and then we click again, it is another answer. We use register 05 subtract with the value of the R05 and -1, and we display it to the register 05. And last step, we're going to save the program. We click here for the bottom save here, and then we're going to choose our file, and we click submit. So these are my explanation about the CPU instruction. Thank you.